Alrighty. Well, thanks everybody for joining our September NASEO Buildings Committee meeting. Today we'll be discussing low-embodied carbon and energy-efficient residential construction. Embodied carbon, which is the greenhouse gas emissions associated with the materials and construction process of buildings, has become a focus area in federal and state level policies and procurement processes. So today we're very happy to be hearing from insulation and siding industry representatives, specifically the Vinyl Siding Institute and Cellulose Insulation Manufacturers Association, on their members' efforts to offer cleaner and more sustainable building materials for residential construction. And we'll also welcome the U.S. Green Building Council for a discussion on voluntary standards for product transparency and life cycle analysis. So super excited to have all these experts on the line with us. And then within the context of building material manufacturers and other manufacturing industries that are moving the needle and decarbonizing their products and processes, I think it's also worthy to plug the NASEO Industrial Working Group that our colleagues Rodney Sobin and Sam Kramer lead. This working group helps state energy offices enhance resources to help manufacturing industries meet their goals and also advance state objectives for economic development and competitiveness. And I guess, Ed, if you're able to drop the link to that working group website, that could be a helpful resource for those on the line to refer to. I don't know if Rodney has joined us on the line yet, but he, as always, keeps this webpage fairly updated and populated with the latest and greatest resources out there. And actually just this morning brought to our attention a forthcoming grant program from EPA funded through the Inflation Reduction Act called Reducing Embodied Greenhouse Gas Emissions for Construction Materials and Products. I think the guidance for this specific grant opportunity is still forthcoming, and when it rolls out, these grants are going to help businesses develop accurate environmental product declarations, facilitating the reliable tracking of emissions associated with the materials and products that these businesses and manufacturers produce. And according to the latest press release on these impending grants, there is an email account that any questions can be directed to. I think it's embodiedcarbon@epa.gov. So those are a few things to keep in mind. But with that, I am very excited to introduce our panelists today. Teeing up the conversation, we'll have Wes Sullins, Director of Materials and Resources at the U.S. Green Building Council, followed by Rachel Stern, Executive Director at the Cellulose Insulation Manufacturers Association, or SEMA, and Matt Dobson, Vice President at the Vinyl Siding Institute, or VSI. And I believe everybody can see Wes's slides pulled up. So if that is the case, Wes, over to you.
Great. Thank you for having us. And let's just jump right in. So yeah, as you mentioned, I work at USGBC on the lead team for materials and resources, and happy to kind of go through what we're seeing as trends for embodied carbon and also connections to what we're doing with LEED. The next, please. So why are we all here? The first kind of slide is a pie chart that I'm sure many of you have seen something like this, where it just shows the building operations are a major part of annual GHG emissions. But what we're seeing and what's coming into focus is the impact that materials have. So the embodied carbon of the materials that make up our buildings and our spaces. And if you click one more time, I think this is important because as we get more efficient with our buildings, the ratio of embodied to operational emissions in new construction really starts to change. Because if we're counting on those operational energy savings from efficiency and things, but if we're starting to build net zero and have renewables and clean energy and all that, embodied energy becomes a much more bigger piece of the pie, kind of a focus area. Next, please. And so with that, there's a lot of jargon and terminology around embodied carbon. So I wanted to do just a couple things on setting the stage for some of the acronyms you might all hear us thrown around. But as you've probably seen, there are these life cycle assessment stages that have these kind of the product, construction, use and maintenance, and end of life phases. you'll see these often referred to as the A through C phases, or even a D phase sometimes for like other things that aren't captured here. But they try to measure the life cycle impact of a thing, a product, a material, a building, whatever it might be. And they use terms like cradle to gate, cradle to grave, et cetera. But what's important is for LCA, that's not just embodied carbon. It's not just GWP. We're also looking at other impacts like the ones at the bottom there, eutrophication, ozone, smog, et cetera. So the life cycle is really a way to look at anything you're doing from a building to a product to anything else from a holistic perspective. Next, please. And this is a graphic I want to just share. Next week is our big conference, Green Build, and we're going to have lots and lots of good content on embodied carbon, one of which will be a report we're releasing with RMI on how to drive down embodied carbon in buildings. And this is one of the infographics that are that's in our report. But just wanted to paint the picture of oftentimes you'll hear about whole building LCA or whole life carbon assessment, and they get confused with things like an upfront material carbon accounting. So we wanted to kind of share the differences here. Whole building LCA means you take all of those impact categories, you know, GHGs as well as eutrophication and some of the other things as well, and you look at the whole building's life cycle from A to C, from start to finish. A whole life carbon accounting assessment does that same thing, but just for the carbon parts. They don't look at the other things, the other impact categories. And then an upfront carbon assessment, this is more like what you might see in the EC3 tool, which I'll talk more about later, which looks at the whole life of those upfront material emissions just from embodied carbons, the GWP only. So just want to set the stage a little bit on some of these terminologies. Next, please. And then an EPD is really a nutrition label for a product. Of course, everyone probably knows what these are now, but they do report all those life cycle impacts beyond just carbon. And interestingly, or fundamentally, EPDs are created by product category rules. That's something that typically industry groups will create for their product category, and it sets the rules for how you do the LCA for that type of product. And the EPD is really a disclosure. It doesn't mean you're necessarily a better product than something else. It just means you're disclosing the impacts in a public way that's consistent from one product to another. Next, please. And so where we are today, and you kind of see on this chart, is we are at the bottom of this kind of rapid advancement of where we need to be. Because I'll just say that, you know, we've spent the last 40, 50 years working a lot on operational energy efficiency, and that's been great. And we've had a lot of time to perfect that. And now kind of zero energy buildings or even net positive buildings are within our reach. You know, we can build them. There's case studies. You've seen them. We need to do that same type of innovation and get to where we need to be of carbon storing materials, but much, much faster. We don't have 40 years. We've got maybe 10 or 20, right? So if you click one more time, there's a call to action here. And again, this is from our report with RMI, but we must accelerate our position on this curve to meet thresholds. The time to act is now. And a lot of folks are acting now. Next slide, please. We are making progress. There's a lot of policies that have put in place. Some have been around for a while. Like on the left here is the Buy California Act, Buy Clean California Act, and some of the UK standards and EU framework. Those have been around since around 2017. But you see, as the timeline progresses here to current day, lots and lots of policies are popping up. The most recent being the California Green Building Code, which now has embodied carbon as a mandatory element for larger buildings in the building code starting next year. So that's a big change. You see a lot of other policies. We have the federal Buy Clean standard, which is looking at similar things like California for product-specific limits of embodied carbon. And we're seeing more and more of these policies every day. Next, please. We really need to speed those up. And now when we look at LEED, LEED's been around since the 90s, late 90s, right? And the rating system that's continuously evolving. In 2013, 10 years ago, we developed LEED version 4, and we introduced some of these concepts of life cycle analysis and transparency. Up until that time, our attributes for products and materials had been around kind of single attributes like recycled content or sustainable wood or whatever that might be. But we wanted to really focus on holistic life cycle analysis of products. So EPDs, whole building LCA, ingredient disclosure, those were all added to the rating system. And they didn't get a lot of uptake at first because these were very new concepts. But in the last 5 years, and with LEED version 4.1, which is an update, we've seen a lot of more interest and uptake of these credits. And on the next slide, you'll see sort of a trajectory of some of those trends. Oh, I guess that's coming later. But this one, let me share the strategies we do for embodied carbon and LEED are threefold. There's sort of things that the design team can do, which is first you kind of reuse a building and then use your LCA to inform your design and drive down carbon. And you see kind of the strategies in blue there. There's reuse, dematerialization, et cetera. Then there's things that product manufacturers can do, and you'll hear about some more of that today on this call. They can do things to optimize their products. They can switch to renewables. They can use recycled content. They can put clean energy in their production. Lots and lots of things they can do as a manufacturer to drive down carbon of their products. And then there's a construction team. Once you've got this great design and you've spec'd all these great products, the construction team is the one who puts that all into practice. And they can do things like reduce waste also, which has embodied carbon implications of things not going to landfill or being incinerated, et cetera. The next slide, please. And so this is the one with trends. Since the last few years, we've seen what you see on the left there is 2020 up until pretty much current day. Credit usage of the product and material related credits in LEED have skyrocketed, really. We went from, if this chart went to the left a couple more years, you'd almost see zeros there for EPDs because there just weren't that many, not many project teams were prioritizing it. But here we are today, and there's about 7,000 projects are using the EPD credit. And if you click one more time, there's another stat that comes up. We're at a point where EPDs are now the most popular credit in the materials and resources credit category. And about 80% of all certified projects get at least one EPD credit point. And that point rewards teams for picking 20 products that have EPDs. And many projects are getting 40, 50, 60 products and getting extra credit for that. And we're also seeing about 25% of all new projects are attempting whole building LCA. And that was down, that's up from a few years ago, there was almost zero that actually got that credit. And now we're seeing a great increase in projects pursuing it. So lots and lots of important things happening in embodied carbon, and we're seeing that reflected in the rating system. Next, please. One of the things we're piloting and testing in LEED is this procurement of low carbon construction materials. The idea here is that there's a lot of EPDs in the marketplace now for certain product categories, and we got lots of excitement around, can we kind of put together all the EPDs we have and create a carbon score based on those materials and reduce by some amount. And there's a tool out there called the Embodied Carbon of Construction Calculator, EC3. That's a free resource. It's been out there for a couple of years now, and there's a pilot credit in LEED that allows you to use that or other tools to develop kind of a whole project or as much of a project as you can. You develop a baseline, and these are all based on EPDs. You develop a baseline for what the average is for those types of products. Then you calculate a verified reduction by what products you choose that are better than average. And then you calculate that difference and get points as you see on the screen here. And that's been a pretty popular credit and lots of interest in use of this type of analysis tool. And also, I think it's looked at, it's helpful in things like the Buy Clean policies as well, because it's a place to take all that EPD data and make it actionable. Next slide. So just to kind of sum up here, it's great to focus on those kind of product swaps, but something that we've been really trying to advocate here at LEED and USGBC is you need to look at all of the combinations to drive deep reductions. And oftentimes you'll see policy things that just drive on one of these attributes, like maybe they look at recycled content or they look at low GWP products. But really, if we can do all these things, reuse first and then have a project that really fits its size and is as compact or is maximizing its potential for the building, you optimize the structure, you don't over engineer it for things that aren't necessary. And then you choose low carbon products once you have that design spec. That's how you get to truly optimize buildings and see large reductions. Next, please. I think it's my last slide, which is just a little plug for LEED. We are currently working on LEED version 5. There will actually be a version of for existing building that comes out next week at Green Build. But the new construction rating system, we're finishing up this year to bring out to the public next year. And there's going to be a lot on embodied carbon. We're going to have hopefully more points for it. And we're going to be focusing on all the things you just heard, from whole building LCA, to product-specific material categories, and we won't be forgetting the other attributes like sustainable sourcing and circularity of products and materials as well. But look for that in the coming months. And with that, I will conclude my part and pass it off to our next speaker.
Great. Thank you so much, Wes. Rachel, I believe your slides are next, and this is Wes's contact information. Take it away, Rachel.
Awesome. So thank you to Jasmine and Ed for extending the invitation to serve on this panel. My name is Rachel Stern. I'm the Executive Director of SEMA. We are a trade association made up of 17 manufacturers and 16 affiliated members across the US and Canada, dedicated to ensuring the highest quality cellulose insulation products and standards. Next slide, please. So for those of you who don't have familiarity with our product, we're an alternative to the pink stuff. Cellulose is composed of 85% post-consumer recycled newspaper and cardboard. Our product used to be more gray in color, but it's increasingly brown. Thank you, Amazon. The other 15% of the material is fire retardants, particularly boric acid. Our insulation is non-toxic, it's non-harmful, doesn't have any detriments to homeowners or installers. I'm sure many of you are familiar with fiberglass bats, which can resemble the texture of cotton candy threads. Another common insulation product is spray foam, which basically looks like shaving cream when it's installed. And all insulation products have their benefits. Cellulose is the only carbon storing insulation commercially available. And not only that, it takes the cake for retrofit applications, including attics and exterior sidewalls. We have a significant presence among the weatherization assistance program because of the ease of install and the fact that it has the lowest embodied carbon, and also just from a cost standpoint, it's pretty much on par with fiberglass bats. And just a fun fact for you, Thomas Jefferson used a form of cellulose insulation to insulate his home at Monticello a few centuries ago. And next slide, please. So here's the hard part for everyone in our industry. How many homeowners care about their insulation? So we care about aesthetic elements like countertops, fixtures, what are the paint colors? But only when you get your first energy bill, and remember the time you wore a sweater in one room and then a t-shirt in another room on the same day, do we pay greater attention to the energy efficiency of our homes. And we certainly pay less attention to the embodied carbon of the insulation used inside these homes. So this chart shows 3 recent studies of new home construction in Canada, which found that after concrete, insulation was the second largest emitting product category, representing 15 to 26% of total emissions. When a homeowner does a deep energy retrofit, insulation products represent an even more significant portion of the overall embodied carbon impact, with a range of 55 to 80% of the total embodied carbon of a deep energy retrofit. And next slide, please. So the good news, though, is that more prospective homeowners are paying greater consideration to the health of their home and their health inside their homes. So, this often includes factors like air quality, but it also includes comfort. And I don't know about you all, but I live in an uninsulated apartment building with leaky windows and loud neighbors. And, having some of these factors addressed would make things far more comfortable. So cellulose addresses both the thermal comfort as well as acoustical needs of homes of all types. And next slide, please. So, builders, homeowners, designers all have numerous insulation materials to choose from when considering new construction or renovation. The range of embodied carbon impacts, though, is wider for insulation materials than for any other category of building materials. And bio-based insulation materials, like those that you see in the lighter blue at the top of the chart, provide net carbon storage in the building, providing a win-win scenario of reduced operational and embodied carbon emissions. And you'll see the term dense pack next to the row listing cellulose. So for those who are unaware, dense pack is a form of installing cellulose where you're using a netting to hold the insulation in place. And you'll generally see that in new construction. Next slide, please. So Wes talked about the EC3 tool for measuring embodied carbon. I want to highlight the BEAM tool, which was developed by Builders for Climate Action. So this program is also free to everyone, and it's primarily used to assess embodied carbon in residential structures. And next slide. The biggest differentiator, though, between EC3 and BEAM is that BEAM is currently the only tool on the market that uses a consistent approach to calculating the impacts of carbon storage in the building materials. And the folks at Builders for Climate Action, and just, you know, shout out to Chris Magwood, who some of you may know, and he's also at RMI. So the team at Builders for Climate Action worked to develop a carbon storage methodology that's science-based, it's transparent. There's, you know, they're bringing in other verified inputs. It's also easier to identify the materials with high climate impact and compare that with alternative greener options. Next slide, please. So recognizing that insulation products have very different climate impacts, from high emissions down to net carbon storing, it's helpful to understand what that means for emissions at a construction project. So let's take this DOE model home as an example. Again, you can see in the diagram the square footage of the insulation areas and just the dimensions of the home. And next slide. So cellulose stands out as having a significantly lower, actually negative, embodied carbon emissions at installation compared to the other insulation types. We offer 124% less emissions than the next closest option, which is fiberglass bats, and 719% lower than closed cell foam, which with an HFC blowing agent. Next slide, please. So this graph presents a closer look at embodied carbon when comparing cellulose with the other materials in this home for Climate Zone 5. So when you're totaling the emissions from both wall and roof insulation for Climate Zone 5, cellulose offers a net storage of 2,644 kilograms of carbon dioxide equivalent, the kg CO2e, well, the closest competitor, our friends with a fiberglass, emit 1,611 kilograms of carbon dioxide equivalent. And obviously you see at the end there, closed cell foam with HFC blowing agents has a significantly higher kilogram of carbon dioxide equivalent. So at the level of a single home, so these differences, if you can go back, yeah. These differences in embodied carbon are substantial, but extrapolated to typical new home construction across the US and Canada, it really becomes increasingly clear that the use of carbon storing insulation materials can alter the emissions profile of new homes and just climate impacts overall. And then next slide, please. As for our EPD, so SEMA first developed its EPD in 2018. We are approaching renewal next year. However, we're not really taking any steps on that until the product category rules for building thermal envelope insulation are updated. So our industry collectively met and we hired a facilitator to collect comments and organize a committee with representatives from all segments within the insulation industry to review the comments. Obviously, our biggest advocacy point is for carbon storage, which is also consistent with ISO standards. And this is a lengthy process. You've got a lot of comments, a lot of different folks involved, advocating for or against changes to the product category rules. So we're not really while our EPD does expire at the end of next year, we're not jumping on the gun to start collecting data from our members until we have a greater sense of when that PCR will be finalized. And right now we're kind of in the early stages of getting a LCA practitioner on board. Now that LCA practitioner will collect data from each of our members, and then we're going to find a program operator to make the EPD. Once that's done, we'll share it with the building community so people have the most accurate information about our product and how cellulose plays a role in reducing the embodied carbon of buildings. And last slide, that's all I have. And if there's any questions, I'm happy to address them during the Q&A. Thank you.
Thanks so much, Rachel. And got queued up here our last presenter, Matt Dobson. Over to you, Matt.
Great, thanks Jasmine and Ed for having the Vinyl Siding Institute here today. We're excited to join this group to talk about EPDs. It's a pleasure to be here. My name is Matt Dobson. I'm the Vinyl Siding Institute's Vice President. And one of my responsibilities includes focusing on sustainability through our Sustainability Committee. I've been here with the VSI for almost 20 years and have been working on sustainability issues for about that same period of time. In fact, one of my first tasks that Wes will appreciate was I was given when I arrived as an employee at VSI in 2004 was to provide input to the USGBC's Technical Scientific Advisory Committee on vinyl. So I've been working on sustainability for a while. Over this time, our industry has been able to look at the science of life cycle analysis and life cycle inventory and help to bring it to the point today where it's now the main scientific measure on how products impact the environment from many different attributes, including carbon footprint. I'll have a few slides and then hopefully we can have some more discussion at the end. I see a lot of commonality between the first two presentations in mind, so I'll try not to be too redundant, but obviously commonality shows unification as far as what's going on with this science. So next slide, please. As I noted, we began to take our journey almost 20 years ago when we started to look at the science called life cycle assessment. It was really an infancy stage as the federal government's National Institute of Standards and Technology, NIST, developed the science through a software tool called Building for Environmental and Economic Sustainability, BEES as it's called. This program is still in place today and one of the best resources to understand how LCA can be applied with building materials and what components to LCA are in place to comprehensively evaluate environmental impact areas. After that time, VSI working with the wood industry, James Hardy and the stucco industry contracted with UL Environment to develop what's called product category rules, which we've heard about already today. These product category rules set in place a fair and even way to evaluate how cladding should be evaluated relative to its environmental impact. What you're seeing on your screen today is the result of the third edition of our industry-wide environmental product declarations. Quite a bit of data collection and scientific evaluation went into the publication of these documents well before they were released. How this process works is an organization or organizations in this case have to establish rules and requirements and guidance for conducting life cycle analysis. I'm proud to say that the product category rules for cladding were one of the first PCRs, as they're called. This took place just over 10 years ago. Once the PCRs are in place, then manufacturers, or in our case, whole industries, can use the PCR and its guidance to determine what data needs to be collected along the way for the manufacturing process, but also considering the life expectancy of the product, the maintenance, and we saw how much recycling plays a role in the impact of our products with the previous presenter. Wes mentioned that there's an overall impact looked at, and there's 12 environmental impact measures. That data is then collected from manufacturers. Then the LCA practitioner will process and review the data for integrity and then put it into the draft EPD. That draft EPD is then third-party peer-reviewed by other LCA practitioners to make sure that it is in compliance with the product category rules that have been developed. There are 12 environmental impact measures in these EPDs, as was mentioned earlier. The one I want to focus on today is obviously carbon footprint, or sometimes called global warming potential. So carbon footprint, everybody has heard that term, but it's basically the measure of the material and how carbon dioxide is impacted at each stage of the manufacturing process, as well as the use stage and as well as the end of life. Energy is actually closely related to carbon footprint in that the more energy that is used, the more impact it will have on carbon footprint in many cases. So creating more energy efficiency structures not only saves energy, but reduces our carbon footprint in many cases. So that's the developmental process for environmental product declarations and its relationship with carbon and energy. We have 3 industry-wide documents available, and our industry has made steady and conscious progress over the years to lessen the material's carbon footprint. Interestingly, our products are sought after for their use with retrofitting and weatherization programs because they're very durable, but also very light and versatile. The specific category, insulated siding, insulated vinyl siding, is a recognized form of continuous insulation in the International Energy Conservation Code. So as part of the insulated vinyl siding's EPD, it actually includes a credit for its contribution as a form of continuous insulation, similar to the cellulose group that spoke before, but obviously not as big a contributor to insulation as the cavity insulation. We are excited to have a construction detail document underway, which will be useful with the implementation of the Inflation Reduction Act, hopefully in early 2024. Next slide, please, Jasmine. All right, let's get back to carbon footprint. Vinyl siding products in general have a very small carbon footprint, specifically when you compare it to other cladding products. Keep in mind, everything we do has some type of impact and creates some type of carbon footprint, regardless of what it is. We're all here creating carbon footprint, really just sitting here using the energy we're using right now in front of our computers. There are no building materials or anything in general do not impact the environment. So everything has a carbon footprint. Certainly wood as a material is also renewable and is one of the great solutions to our carbon quandary. But it still has a carbon footprint when used as a building material. But its footprint is reduced because it is renewable. Our products are in a good position to help not only limit carbon footprint, but also help to take next great steps that are going on with the International Energy Conservation Code with outboard insulation. 100 square feet of our material has about 9.8 kilograms of carbon dioxide baked into that product. Baked meaning when the LCA goes through its process, you're looking at all the steps along the way, the extraction of the product, if we're using more recycled material, the energy that goes into it, the other materials that go into it, and their carbon footprint. So that's how we can put a number on carbon footprint, which we saw earlier in the program. So it's an easy way to measure the product. But what is 9.8 kilograms of carbon dioxide? What does that really mean? One of the main benefits of environmental product declarations is to provide transparent data on how products are made and then their environmental impact. So this example on the screen now on the right shows how EPDs measure carbon footprint or global warming potential at each stage of the process. It's important because we can then drill down into the manufacturing processes or other processes and look at what improvement or efficiencies can be made, which ultimately will then reduce the impact of the material further. So, you know, the outward facing EPDs is great, but inwardly as manufacturers, it helps us because it helps us to understand how we can reduce our footprint through steps like recycling or reduction in use of different materials through efficiencies. So it's a great process of continuous improvement too, a great component to continuous improvement relative to environmental impact. For specifiers and for those who want to understand materials more and potentially choose products that are actually better on the environment, it also provides that tool. We have actually improved our environmental impact in many categories since over the last 10 years, which you see in the upper left of our screen. So we have been able to reduce our electricity use by 22% by improving efficiencies, using 34% natural gas, again, through continuous improving, and using a lot less propane during the manufacturing process. Further down on the left on the slide, you'll see how vinyl siding compares to other products like brick and fiber cement. Comparing products, you can actually decide on materials that have less of an impact on the environment. So you have the inward look of continuous improvement, but also decision makers can use carbon footprint and now measurable carbon footprint to decide on products that are actually better on the environment. So again, you'll see on the screen vinyl siding versus fiber cement. I do want to point out vinyl as a material is not necessarily pound for pound less impactful, but because of the way that vinyl siding is manufactured, it is extremely resource efficient. So less, going back to smaller structures, less material is obviously a better thing. Similar when compared to fiber cement or brick, they are much less efficient. They use more material, they use more energy to make those products. So I talked about the number 9.8, but it's hard to understand exactly what this means when it comes to building materials, because, you know, building materials is not completely understood by specifiers and others that aren't deeply into the materials categories themselves. So we created an analogy for better understanding here. So in car terms, vinyl siding would be like the hybrid, and a pickup truck would be fiber cement. So we all know about automobiles and what the ones that are more environmentally friendly. So that's a good analogy when you look at vinyl siding versus fiber cement. If you look at brick's going to be the Ford F-150. Okay, brick's going to be the big Ford F-150, and vinyl siding is going to be the Tesla. So relatively speaking, if you take those vehicles and their impact relative to carbon footprint, that's a good analogy, relatively speaking, when you're comparing building products. So let's move to the next slide now that everybody's thinking about driving somewhere. All right, this is my final slide. I'm going to bring environmental product declarations, carbon footprint, and energy efficiency into a forum where it's easy to dive into to see what materials' range of carbon footprint are. It was already mentioned earlier. There's a great tool out there. It's called EC3, and you probably recognize the graphic on bottom left from earlier slides. It's operated by the leading organization on this issue called Building Transparency. It is by far the best tool to make clear evaluations relative to embodied carbon. On the screen, as I noted, is an excerpt from EC3. It's an easy-to-use software tool that's free. I encourage everyone to become familiar with it. So what this tool does is it takes environmental impact declarations that we've been talking about and that are published and that have been third-party reviewed. It brings them into the software, brings the data into the software, then extracts the embodied carbon data in these EPDs, and it begins to populate this embodied carbon data information into a range of what embodied carbon should be in a particular material or particular material category. So you see on the screen, you have different materials. You also have different categories like siding, furnishing, finishes, plumbing, mechanical, etc., sheathing. By doing that, all of a sudden you start to see the outliers, the good outliers, the bad outliers relative to embodied carbon. And outliers, you know, are ones that can be embraced, or maybe they need to rethink how they're doing things based on how they're fitting in with this range. It gives specifiers and decision makers the ability to say, all right, how well are we going to reduce our carbon footprint if we choose these materials and these materials and those materials? This is going to bring down our carbon footprint significantly. It's not it's only part of the equation. I'm not saying this is the whole answer. It's part of that equation. We saw the differences where embodied carbon fits into the use phase and other other parts of the process that get us to buildings. But this is definitely a decision point that can help to specifically reduce embodied carbon through material choice. So I encourage you to look at the EC3 tool as a great central source for all the embodied carbon information in the marketplace. And as you can see, this program is supported by some pretty big organizations. And again, it was great to speak on this issue today. It's an exciting issue, and it's really a way that we can help to make a difference by meeting these goals that are out there to really bring into line what we need to do to keep being good stewards of the environment and help to reduce our carbon footprint, but also help to improve the environment in general. And I'm happy to take any further questions and comments. And it was great to be with you today. I appreciate the opportunity. Thanks, Jasmine.
Awesome. Thanks so much, Matt. And with that, we'll turn it over to audience-led Q&A. So if anyone has any thoughts, reactions, questions to share, feel free to use the chat or use the raise hand function and come off mute. And I think I'll end the recording here as well.